Welcome to homework.
This would be a free body diagram for part A and part B. For part A, we are going to want to find the weight of the person. We're going to apply the sum of its torque. We know that the system is in static equilibrium, so this will equal 0. And this would be equal to m sub b g times 5.0 meters minus the weight times 5.0. And we know that this force is equaling 0 for part A. And we can say that then we're going to take the torque about point B. So force sub B isn't taken into account because we're evaluating at that point. And so the weight would be equaling m sub b g. This would equal essentially 650 newtons. This would be our answer for the weight for part A. And for part B, we know that with the person standing at point D, we already assume that this force sub A is equaling 0. So we can use the sum of force in the y direction. This system has translational equilibrium in the y direction. And so this would be equaling force sub B minus m sub b g minus the weight w. Again, f sub A is equaling 0, so we don't have to account for this. This is equaling 0. Force sub B is then equaling m sub b g plus the weight. This is equaling 2 times 650 newtons. This is equaling 1,300 newtons. So this would be your answer for part B. Now the system, the person moves to a different spot. So this is what the free body diagram would look like now. And here we're applying the sum of torques. Again, the net torque about point B, and this is equaling 0, and this will equal m sub b g 5.0 meters, and then minus the weight times 2.0 meters minus force sub A times 12.0 meters. And so we find force sub A equaling m sub b g times 5.0 meters minus weight times 2.0 meters divided by 12.0 meters. This is equaling 650 newtons times 3.0 meters divided by 12.0 meters, and F sub A is then equaling approximately 163 newtons. This would be our answer for F sub A. For part C, and then trying to find F sub B, we apply the sum of forces in the y. This would equal 0. This would equal F sub A plus F sub B minus M sub B G minus the weight W, and so F sub B would equal M sub B G plus the weight minus F sub A. This is equaling 1,300 newtons minus 162.5. We'll round at the very end. And we find that F sub B is equaling approximately 1,140 newtons. This would be our F sub B for part B. And then finally, for part C, the person moves to, again, a different spot. And so take the sum about B, the sum of the torques, equaling 0. This is equaling M sub B times G multiplied by 5.0 meters plus the weight times 10.0 meters minus F sub A times 12.0 meters. And we're finding F sub A. This would be equal to m sub b g 5.0 meters plus the weight times 10.0 meters divided by here 12.0 meters. So this would equal 650 newtons multiplied by 15.0 meters divided by 12.0 meters. This is equaling approximately 810 newtons. This would be our answer for F sub A for part C. And then we're going to apply the sum of forces in the y direction again. So F sub B would then be equal to m sub B g plus W minus force sub A. And this is equaling 1,300 newtons minus 810 newtons. This is giving us approximately 490 newtons. This would be our final answer for force sub B for part C. Rather, for part D, my apologies. I realized that this was for C and that this was A and B. So A, B, C, and D. That is the end of the solution. Thank you for watching.